All right, so we're going to talk about present value of an annuity amortization. Amortization is paying off debt with equal periodic payments that include compound interest. A present value of an ordinary annuity is the amount you should expect to pay for an annuity. So the present value is going to be the present value of all payments, and note that payments are made at the end of each period. So typically where we see an amortization schedule is if you buy a house, they will give you an amortization schedule, at least that's what I've seen, and it'll show you how your house will go down each month. So you're paying off a debt with equal periodic payments, and it includes the compound interest. So we've got some more formulas here. We've got present value equals your payment. This would be if you're given the I and the N. This would be if you're given R and M and T. Also, we'll have the payment with the present value and the I and the N, or with the R, the M, and the T. All right, let's go look at example 1. So this is 3.4. So for example 1, we're going to find present value given that n equals 40, I equals 0.058, payment equals 135. So we're looking for present value. So we know we're looking for PV. We're given the N and the I in the payment, so that means we're going to use the formula that has those letters. So payment times 1 minus 1 plus I to the negative N over I. So that's our formula. All right, so our payment is 135, and then we have 1 minus 1 plus 0.058 raised to the negative of 40 divided by our 0.058. All right, let's talk about the parentheses we need. We need parentheses for the entire top part, and then we're going to need a set here. So again, we're going to do this part first and then multiply by 135. If you can do it without doing this first, then you go do what you need to do. But typically the students struggle with putting it in the calculator on these parts here. All right, so we're going to have 135. Let's go find our number. So we'll clear. We've got parenthesis 1 minus parenthesis 1 plus 0.058, close the parenthesis, raise it. Now you're not doing the subtraction sign, you got to use the negative sign down by the enter key because it's a negative 40, it's not minus 40. If you put the minus, it'll tell you there's an error. Now let's close that parenthesis. Oops. So let's delete that. I got to go down first, then close the parenthesis. I just closed it and it kept it up in the exponent. So close your parenthesis after you go down and then divide by 0.058 and hit enter. All right, so we're going to multiply that by 15.433,60047. So now I'm just going to do times 135 like we've done in the past lectures. And we're going to end up with 2,083 point. I've got to round to 2 decimal places because we're talking about money. So the 6 will cause the 3 to round up, so 54. Dollar signs go at the front. So the present value would be $2,083.54. All right, let's go look at example 2. So for example 2, we're going to find the payment. Given that the present value equals $12,000 N equals 30, I equals 0.039. So we're looking for the payment. So again, we have N and I. So our payment will be equal to our present value times I over 1 minus 1 plus I to the negative n. So for our payment, our present value is $12,000 times 0.039 divided by 1 minus 1 plus 0.039 raised to the negative 30. And again, we're going to need parentheses on the bottom, and then multiplying the whole thing, so we're going to put some brackets. The top doesn't have anything but a number, so we don't have to parenthesize that. All right, so we're looking at 0.039 divided by parenthesis 1 minus parenthesis 1 plus 0.039, close the parenthesis, raise it up to the negative, not the minus, but again the negative sign of 30. Then back it down, close your parenthesis, and hit enter. All right, so now we have 12,000 times 0.05713. So I'm going to multiply that by my 12,000, and I'm going to get 685.559. The 9 will cause the 5 to be a 6, so 0.56. So in order to have $12,000 in that time, I'm going to have to make $685.56 payments. All right, let's go on to example 3. So example 3 is on our handout. So American General offers, it's a company, so American General offers a 17-year annuity with a guaranteed rate of 9.56% compounded annually. How much should you pay for one of these annuities if you want to receive payments of $800 annually over the 17-year period? All right. So we've got a 17-year annuity. It's got an interest rate. It's compounded annually. That tells us we're going to use the M. How much should you pay for one of these annuities if you want to receive payments of $800 over the 17-year period? So we're looking for how much should we pay for it. So we're looking for the present value because we're given $800 payments. All right, so we're going to buy the annuity. We're going to get $800 payments, but how much are we going to pay for it in the beginning to do that? All right. So this is example 3. So we're looking for present value because we're looking at how much do we need to pay in the present in order to get that in the future. So payment, and then we're going to have 1 minus 1 plus R over M raised to the negative MT over R over M. All right, so present value, we are going to figure out what we're going to pay for it. So it would be a payment of $800, 1 minus 1 plus, our interest rate is 0.0956. It is being done annually, raised to the annually again, times 17, divided by our 0.0956 over 1, which is our R over our M. All right, we have a bunch of 1s again, so let's simplify this down. So it'll be 800 times 1 minus 1 plus 0.0956 raised to the 17 divided by 0.0956. Again, I'm going to put all my parentheses in my red, and here's my bracket. So again, I'm going to put in the bracket part first. So we're going to have parenthesis 1 minus parenthesis 1 plus 0.0956, close that parenthesis, raise it to the 17. Oops, I did it again. Gotta hit delete for that. I gotta go down first before I close that parenthesis for the top, and then divide by 0.09956. All right, let me put that in again because I think I have something wrong here. Oh, you know what I forgot? I forgot the negative sign. It's negative MT. I got a negative 38.928. That doesn't make any sense because I can't get a negative value if I am putting money in. So that told me I did something wrong. I forgot the negative sign on my 17. All right, so let's do it again. So parenthesis 1 minus parenthesis 1 plus 0.0956, close the parenthesis, raise it, use the negative sign down by the enter key, not the minus sign, negative 17, back it down, close the top, and then divide by 0.0956 on the bottom. All right, that looks more correct. All right, so now we have 800 being multiplied by 8.2448 22707. So we're going to multiply by 800. And we're going to get 6,595.858. That 8 will make the 5 round up, so it'll be 86. Again, this is dollar sign at the front, not at the back. This is how much you will pay for the annuity, so that over time you'll get those $800 payments. All right, let's go look at example 4. Example 4 is also on our handout. So eLoan, which is an online lending, not leading service, put an N there, lending service, recently offered 42-month auto loans at 6.6% compounded monthly to applicants with good credit ratings. If you have a good credit rating, you can afford monthly payments of $225. How much can you borrow from eLoan? And what is the total interest you will pay for this loan? All right, so again, we're compounded monthly, so we know that the formula we're going to use will have our M. And we are looking for how much can we borrow, so we're looking at our present value because we want to borrow it right now, and then we're going to figure out the total interest. Okay, so we're looking at, again, the PV is equal to the payment times 1 minus 1 plus R over M raised to the negative MT divided by R over M. So that's the formula. We are looking at being able to afford a payment of $225. And we have 1 minus 1 plus. Our interest rate is 6.6%, so 0.066. It is doing this monthly, so divide by 12. Negative 12 times 3.5. It's 3.5 years. And how do we know it's 3.5 years? So let's talk about that real quick. So we were told that T is 42 months. We got to divide that by 12 months because it always has to be in years, and that will get us 3.5. So that's how I figured out it's 3.5 years, by taking those months. All right, let's finish writing this out. Then we'll divide by 0.066, divide by 12. So again, we got to do the entire top. We got to do the entire bottom, and then we got to bracket the whole thing. All right, so let's go put this in our calculator. So we're going to have parenthesis 1 minus parenthesis 1 plus 0.066 divide by 12, close the parenthesis. Raise it to the negative, not the minus, but the negative, 12 times 3.5, bump it down, close the parenthesis, divide by open parenthesis, 0.066, divide by 12, close the parenthesis. All right, so this will get us 225 times 37.410544421. So multiply that by 225 in your calculator, and you get 8417.37, because the 2 after the 7 will cause it not to round up. So this is how much we can borrow. We can borrow $84,017.37. Now, how much interest was also asked what we would be paying. This is example 4. It says, how much interest is in interest, and we're going to round to the nearest dollar. All right. So for interest, again, we got to do the total payments. So we paid it for 42 months. The payment was $225, and that gets us $9,450. So that's our total payments. And then we're going to subtract out the amount we borrowed, which is $84,1737, and we get $1,032.63. This would be paid in interest. Now, if we were rounding to the nearest dollar, and it depends on what they're asking for, this one would be rounded to 84.17 if we were looking at the nearest dollar. This one would be 1,033 because the 63 cents would round up. So it just depends on where they're asking for that round to the nearest dollar. All right, let's go to example 5. So for example 5, in order to accumulate enough, wrong story, sorry, we're over here. The annual interest rate on a credit card is 18.99%. If a payment of $300 is made each month, how many months will it take you to pay off an unpaid balance of $2,712.37. Assume no new purchases are made with the credit card. Solving the present value formula for this or this, the negative MT or the N, would get you the following formulas, which you can then plug in the values to solve for the exponent of time. All right, so if you get to this problem, you need to use this formula. I have taken the previous formulas and I have solved them for that. You can also find this in your homework, and in the homework it'll show you those problems. So I've printed off the homework so you could kind of see where we're at. So it's this is doing like view an example. So they are walking you through, you're going to find this part, and then they're looking at moving this formula all around. So this is where I got the formula as well, is moving this stuff around. Now this is using the I. There is also going to be where you're going to need to use the R and the M. So it depends on what letters you're given. So I went ahead and put that on here because it's a lot to do. And that way you can just have the formula there. All right, so we are given, in our problem, we're given our R, and we are also given the payment, and we are looking for how long. And we're assuming no new purchases are made. And the payment is made each month. So the periods then are happening monthly if the payment is being made each month. So it's going to be 12. All right, so let's write this out. So we're going to use let me think about this. Yeah. So we're going to use the n equals. And we're going to do the negative one. I see I have a negative MT and an n equals. The difference between the n and the MT is n is m times t, which is, we see that up here. We have n and we have MT. If you're doing the negative MT, it looks like this. If you're going to do n, which is what we're going to solve for, the negative has to be on this side over here. We're going to put the negative over here. So we're going to use this formula. So this will be example 5. So we have n equals negative the ln of 1 minus r over m times your present value divided by payment and then divided by the ln of 1 plus r over m. So pay attention that in here we have some extra parentheses because we've got to multiply this times this. We're going to take 1 minus this and then divide it by 1 plus that. Alrighty. So this will get us negative the ln of 1 minus, our interest rate is 18.99%, so it'll be 0.1899. They're being done monthly because you're making monthly payments in, times our present value of 2712.37 divided by the payment, and the payment is $300. And then we're going to divide that by the ln of 1 plus 0.1899 divided by 12, because it's again the r over the m. All right, let's see if we can put this in our calculator correctly. All right, and it's going to be the negative of that. So we're going to do the negative of ln parenthesis 1, oops, I don't have to put in the parentheses, sorry. Delete that. When you put, let's clear. So we're going to do the negative of ln. The parenthesis automatically comes up on the ln, so I don't have to put that one in. 1 minus parenthesis 0.1899 divide by 12, close that parenthesis. Open the next one, 2712.37, divide by 300, close that parenthesis, divide by ln, it opened the parenthesis already, 1 plus 0.1899, divide by 12. Close the parenthesis and hit enter. Whoop, I did something wrong. All right. So ln 1 minus parenthesis 0.1899 divide by 12 parenthesis 2712.37 divide by 300, close the parenthesis, divide by the ln of 1 plus 0.1899 divide by 12, close the parenthesis. All right, what are we doing wrong here? Oh, I got to do another. I think I'm not closing out the first part. All right, let's do it again. So sorry. So for you, that'll be like, yeah, that's where I'm stuck. All right, so 1 minus 0.1899 divided by 12, close that parenthesis, open the next one, 2712.37 divided by 300. We got to close this parenthesis and then close the top. That's what I wasn't doing. You got to close that other parenthesis out there. Now divide by our ln of 1 plus 0.1899 divided by 12. There we go. All right, so the parenthesis I was forgetting was this one here. You got to make sure you close that top, because we closed that one. You got to do that second parenthesis right there. All right, so this equals 9.83420,988. All right, we are going to round that to the nearest integer, so 9.8 will become 10, and this is in months. So in 10 months, we will, because it says how many months will it take to pay off an unpaid balance if you're making that kind of payment. It'll take you 10 months to pay off that card. All right, so don't forget that parenthesis, and then you'll get domain errors. All right, let's go to example 6. So on example 6, you want to purchase an automobile for $22,099. The dealer offers you 0% financing for 36 months or a $2,500 rebate. You can obtain 6.6% financing for 36 months at the local bank. Which option should you choose? So for 0% interest, the payment is going to be found by taking the payment will be equal to the present value, which is going to be your loan, divided by the number of periods, which are going to be 36 months. For the rebate, we're going to use the 6.6% interest. We'll use the payment formula. And remember that 36 months, we got to divide that by 12 months, will get us 3 years. And our periods are also monthly, so M is going to be equal to 12. And then we'll use that formula. All right. So we have two options here. So the first option, so option 1, is our 0% interest. We're like, hey, this is great, no interest. So let's figure out how much we would pay. So this is where we're going to have our payment will be equal to the present value divided by the number of periods. I know you guys see that now as hashtag, but it also stands for number of periods. So our present value, the amount we want to borrow for the car, is $22,099. It is 36 periods because we're doing 36 months. This, you leave it as months. You do not change it to years because that's how many periods or how many payments we're going to make. So divided by the 36 payments, we're going to get $613.86. This is how much your payment would be for option 1. All right, let's go to option 2. Now on option 2, we're going to do 6.6%, but we get a $2,500 rebate. You can obtain a $2,500 rebate and get 6.6% financing at the local bank. All right, so if we get a $2,500 rebate, the cost of the car changes. So we take $22,099 minus the $2,500 rebate will actually get us $19,599. So we're not going to use the $22,099 because we got a rebate. So that changes what we're paying for the car. So now we're going to have our payment will be equal to our present value. And we'll have our R over M divided by 1 minus 1 plus R over M to the negative MT. That'll be the formula. All right, so we're looking at our payment will be equal to our 19,599 times our R. Our rate is 6.6%, so 0.066 divided by 12 because it's monthly payments, divided by 1 minus 1 plus our 0.066, divide by 12, raised to the negative 12 because that's still our M, and it's for 3 years. So here you're going to use 3 and not 36 because you're using T for time. All right, so let's put in our parentheses. So we're going to have the whole bottom, we're going to have the whole top, and then we're going to bracket. All right, so let's go do our bracket part. So we're going to have parenthesis 0.066 divide by 12, divide by parenthesis 1 minus parenthesis 1 plus 0.066 divide by 12 raised to the negative of 12 times 3. Bring it down, close the parenthesis. So we're going to get 19,599 times 0.0306, 94539. When we multiply that by 19,599, we get 601.58. The 2 will not round up. 601.58. So here is this payment. So which one do we choose? Do we choose to make $613 payments or $601 payments? Here there's no interest. Here there's interest, but actually because we get a rebate, our payments are lower. So we actually have a lower payment of about $12.28. Okay, it doesn't say, so which, just says which option should you choose. So the difference, if we take the 0% minus the rebate rate, we have 613.86 minus 601.58 gets us $12.28 a month we'll save. So we're going to save $12.28 per month if we do that. Now, how much is that over the lifetime of the loan? Because you're like, well, $12 isn't very much. But over 3 years, how much will that be? So we have 36 months times the 12.28 per month will get us $442.08. So this is how much we're going to save. If we go with the rebate, we'll save $442.08 over the lifetime of the 3-year loan. So, rebate's a better option.